Right. In our previous class, we started EIGRP Advanced. Yesterday, we did a lab on EIGRP summarization, both manual and auto summarization. We saw the variation in summarization between two different EIGRP versions. Let me repeat that quickly. If you are running iOS 15 or later version, then in EIGRP, summarization is off. Summarization is disabled. So what is the other side of it? If you are using the earlier version, summarization is on, enabled by default. So in earlier version, whenever people used to do EIGRP configuration, they used to say no auto summary, no auto summary. Always they will type this comment, no auto summary. But in the newer version, Cisco said, why you are unnecessarily typing no auto summary? Let me only do no auto summary by default. So they disabled it. I don't want to give you pain, so let me off it. So they have offed it. Auto summarization is off today. And also we did manual summarization. I hope you remember this. This is the command to go under interface and do manual summarization. If you are not, you were there present, but if you want to go through the video later, you can go through this. This is the lab that we did. So this is what we did in our previous lab. We went under the interface because we did not want to send a detailed network in the serial 00. We want to send a summarized route like this, not like 17, 172.16.2, 172.16.1. We do not want to send all this subnetted network. We would like to only advertise in a summarized form. So we say 172.16.00. Actually, they have done a mistake in this picture. What is it? There is a mistake in this picture. Let me see who finds the mistake. No. No. Some other mistake. Is that a mistake? No, actually, there is no mistake. There is no mistake. Okay, so let's go. You see this one C routing table, router C's routing table before summarization. Even in the lab, I showed you this. I'm going to show you again in this presentation. In router C, before summarization, after summarization, after you say the summary address command, route pointing towards null 0 gets generated. In our lab, I showed you before summarization, this was not there. After summarization, it appeared. Okay, now we are getting into an important topic. Why it is so important? Because EIGRP alone can do unequal cost load balancing. EIGRP alone can do Okay. All protocols will do equal cost load balancing up to 4 paths. You can up to 4 paths. All protocols can do equal cost load balancing up to 4 paths. If you have 10 paths, only 4, any 4. If you have 10 equal cost path, any 4. And in the older versions, you can maximum make it to 6. But in the newer versions, you can have up to 32. In the real world, we don't need those things. Those many we don't need in the real world. 32 equal cost path, you will not find anywhere. Yeah, so you have option of tuning it up to 32. You have an option of tuning it to 32. But by default, it will support only up to 4. Now, by default, EIGRP supports only equal cost load balancing. Only equal cost load balancing. Why? Because unequal cost load balancing is disabled by setting the variance value 1. There's a value called variance. By setting it to 1, sorry, I'm teaching the next page here. This doesn't mean that. In next page comes the variance and the multiplier value. Let us not talk about that now. Let us see what is explained here. You see, I told you by default, up to 4 paths can be used for load balancing by default. If you want to increase, you can increase up to 32. What if I do not want load balance? I don't want to do load balancing even with this default 4. I just only want one path. For that, what you need to do is you need to set max path command. What is the command? Max path. When you set max path is 1, which means you want only one path, you do not want load balancing. Hope you understand this. You can try this in the lab, or when I do the lab, remind me this. Whenever we have multiple paths with same cost, up to 4 paths will be used by EIGRP. But if you don't like it, you can set max path 1. Or if you want more than 4, then you can set max path equal to, let's say, 10 or 32. Up to 32 you can. I've also seen some Nexus supports up to 64. Yeah, 64. Sorry, this is the topology. I have put the IP address wherever is necessary, including the loopback interface for testing the load sharing stuff. And if you notice this side both are gig ethernets. And here all are fast. Anyway, what I'm trying to say is the cost is not going to be different. In this link, in this path and this path, the status is same, the cost is going to be same. Now when I run EIGRP, I'm expecting 2 paths to reach 2.2.2.2 from router 1. And I expect 2 paths to reach 1.1.1.1 from router 2. Because by default it supports equal cost load balancing. Let me go enable EIGRP. Router EIGRP 10.100, network 10, network 20. And let's see whether the summarization is off or on. Show IP protocol. Summarization is in. It is on. Okay. So it is summarization is on. Right now there is no summarization. Okay, the max path by default is 4. No problem. Let's go to this one. Oh no, one more thing I have forgotten to advertise in router is, you see, the 1111 network is not advertised. Router EIGRP 100 network 1 done. Show IP protocol now. Look at this. This 3. So right now the summarization is happening for these 2 because summarization is on by default. What is next? Let's configure EIGRP on the other router. Router EIGRP 100 network 2 dot and network 20 dot network 10 dot. Okay, so we got, oh no, I made a mistake. We don't have 20, we got 10 only. 10.20 and 10.10, so that's not needed. This is not needed. Even in R1, the 20 is not needed. Anything that starts with 10, we don't have 20. That's a mistake I made, and you also didn't find. Where is 20? We don't have 20 in our network. Show me 20. There is no 20. Do you have 20? Okay. So now what I'm saying is show IP EIGRP topology. If you see here, for 2222, the advertised distance is also same via both the path G00 and G01, and the feasible distance is also same. As a result, you have 2 successors. You can go via the upper path, you can also go via the below path. 2 successors. Show IP route, we got 2 successors. 2222 or 2 paths. Upper path, below path. 10 is upper path. 10 20 is below path. Now let's see, show IP protocol. You can see here max path is 4. Router EIGRP 100, you see max path. The command is max path. No, this is a simulated version I don't support. Sorry. The command is, I'm very sure it's max path, okay? Max path. If you say max path 1, right now what is the max path? 4. If you say max path 1, then any one of the path will be used. If you say max path bigger than 4, and if you will have more paths, all paths will be used. Even though here max path is 4, I have only 2 paths, and all the 2 paths are used. Right? So when we do in EVE, I'll show you. Now let's go back to our presentation. All right, now next, unequal cost load balancing. EIGRP can even do unequal cost load balancing. What is unequal cost load balancing? For example, in our topology here, what I have is, let's say 10, 10, 10, 15. So what happens to reach 2222? The advertised distance and feasible distance is 20 from here. Whereas from here it is 30, 25. Assuming this as a router, okay, it's 25. 15 plus 10, 25. The upper path, 10 plus 10, 20. This is what called as unequal cost. Now, question to you is, if this is path A and this is path B, which path will be seen in the routing table? A or B? Okay. If path A is seen in routing table, will it be seen in the topology table? My question is, will this path A will be seen or not? It will be. Very correct. Now next question is, will path B be seen in the routing table? No. Will it be seen in the topology table? Why? No, no, no. In the first chapter, we learned something called feasibility condition. What is that? The advertised distance, which is 10, should be less than the successor value. Because this is true, because this is true. You remember these things or not? Feasibility condition we learned. Only if it is qualified to be a backup path, then it will be there in the topology table. But in order to bring it to the routing table, what need to be done? See, if this route is not in the routing table, it cannot be used for load sharing. Here it says unequal cost load balancing is supported. Unequal cost load balancing is supported. But by default, variance is 1. What is variance? 20, this 20 multiplied by 1. What is the answer? Any path whose metric is 20 will be used. Will this be qualified? No. Path B is not qualified. But if this path is already there in the topology table, you can simply go to this variance and make it as 2. What is the answer now? 40. If the variance is 2, then multiplier value is 40. What does this mean, you know? Any path whose FD is less than, what is FD? 25 is an FD for this path. 20 is an FD for this path. If FD is less than or equal to 40, consider in the routing table. So by setting variance, you can make even this path to be available in the routing table. You understood? You see, what is variance? It is a multiplier value. Allows the router to include routes with a metric smaller than the multiplier value times the minimum metric route for the destination. For example, see this picture. I'm going to ask you some questions. I'll give you 2 minutes. Go through this picture. Which among these 3 routes will be the successor route? Right. Next question to Sam. Will path via B be seen in the topology table or not? Yes. Why? Correct. It meets the feasibility condition. The advertised distance is 10. 10 is less than this 20. Yeah. This 10 is less than 20. Feasibility condition is met. Okay. To Bala, will the path via D be considered in the topology table? No, because it didn't meet the feasibility condition. So now only these two paths will be there in the topology table. In the routing table, only path via C will be there in the routing table. But by making the variance to be 2, when you put variance 2, 20 will be multiplied by 2, and the answer is 40. Because this 30 is less than 40, this will also be seen in the routing table. So load sharing will happen using across via this unequal cost path. Understood? Now, load will be shared, but not equally. According to the capacity, you see, here less metric, here more metric, right? So if you have, for example, I'm saying 1000 packet, uh, let's say like 650 packets will be sent via this way. 450 will be sent via this way. You understood? That is automatic. You don't need to worry about it. EIGRP algorithm will take care of it. I'm saying if the path is unequal cost path, we use variance. When we use variance, those paths, unequal cost paths, will be appearing in the routing table with various metrics. So EIGRP needs to do some justification. It cannot send the same amount of packet via different metric paths. The path with better metric means more bandwidth, more packets should be sent. So the path via C will take more traffic than the path via B. Is this understood? All right, this we need to do the lab and see. We'll do this in the next class.